Again, these are more difficult factorization problems. And what you want to pay careful attention to is making the factorization a little bit easier for you. So, kind of just look at the first guy, and this is the first guy right over here. Just to reduce the degree of it, I would be factoring an x out immediately. All right, so what do you get over here? X, then you get 6x4, that's now a fourth degree polynomial, plus x cubed plus 3x squared minus 6x minus 4. And, I still would go for the rational root theorem and looking for, a trial root and then getting a factor for it. So the rational root theorem says that if there are rational roots, and if there aren't, I'm done with the problem. But it would be the factors of 4, which is 1, 2, and 4, over the factors of 6, which would be 1, 2, 3, and 6. Now, granted, it is a long list. It really is. What I suggest you do is, and again, you're allowed to use calculators, take a stab at it. And what I mean by that is look at this and try to come up with a root that's going to produce a 0. And I'm going to say that probably the first one you'd stumble on, the easiest one, is actually 1. So x equals 1 makes that 0. So then what do you know? You know a factor is x minus 1. Now, by the way, then you got a cubic problem. And if you want to, you could do that, but I'm going to look for another root. And my other claim over here is that the other root you'd find, and again, I'm not saying you'd find it immediately, would be minus 1/2. What I mean by that, if you plugged it in to the polynomial 6x4 plus x cubed plus 3x squared minus 6x minus 4, it would produce a 0. Now, what does that mean? It would mean 2x plus 1 is a factor of it, all right? And then what do you get over here? You do a long division, you expand this, and you divide it into this up here. And you get a quadratic. And the quadratic you'd get is the one I'm indicating over here. So you get the factor x, you get the factor x minus 1, you get the factor 2x plus 1, and after the long division, you'll see this one over here, which is not going to be factorable over the integers, all right? Now, granted, these are more difficult problems. There's no doubt about it. Like factoring that takes time. There's no doubt about it. Now, some people say, I have special talent for this. Good for you. Most people don't. They're struggling with it. Here's the key word, though. They tell you there's a GCF, there's a GCF. If you can't find the GCF, though, the GCF is 1. What am I going to do with the second one? Same story. But what I'll be doing over here, factoring out an x. What do you get? You get 12x4 plus 8x cubed minus 3x squared minus 10x minus 4. What am I doing over here? I'm going to list the rational roots to it. And the rational roots, when I say candidates, I should say, the factors of 4, which are 1, 2, and 4, and then the factors of 12, which, kind of ridiculously long, 1, 2, 3, 4, and 6 and 12. Right, but I would not test them all out. And again, you're more than welcome to use a calculator to do that. And you really should learn how to use a calculator. It really speeds the process up greatly. So if you did that, you're going to find out, that 1 doesn't work, 2 doesn't work, 4 doesn't work. You'd have to go to the fractions. And the first fraction you'd hit upon would be x equals minus 1/2. All right? And if you do that, I hate to say this to you, you could test the other ones out. They're just not going to work. All right? So what do you get here? Well, you get this over here. You get x. And again, let me just point out what this means. This means 2x equals minus 1, or the factor would be 2x plus 1. And then what you do a long division, and you're going to get a cubic here. All right? So my claim over here, if you do the factorization using the rational root theorem, you'll get x, 2x plus 1. And if you do the division, you should get this over here. All right? Now, granted, it's a nasty cubic. There's no doubt about it. But I hope you start to realize that you're seeing something they have in common at this point. And what do you see in common? You're seeing the x and the 2x plus 1. So what's the GCF? X, 2x plus 1, If you want to multiply it out, you can. Doesn't make it any better, by the way. All right, let me remind you again who I am. My name is Ron Bannon. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. Again, if you have questions or concern related to the document, please get in touch with me and share your concerns. All right, try to improve the document. Thank you.